Hello everyone, welcome to the fourth and final video of a series chapter with the roots of unity. I'm Shomo and today we'll be talking about convergence and the sum to infinity. We'll start with a very basic series summation. We have the limits of 1 and n. However, if instead of these limits, you were told to find the sum of this to infinity, well, what do you do? You might say that Shomo, this summation is obviously equal to infinity, which you are correct. If we put in infinity instead of n in the formula, we have infinity. So this sum keeps on increasing without any control. This increases without any limit, and this increases to infinity. So we say that this summation series, diverges. If you consider the sum to infinity of minus 3r, you have negative infinity, which does not increase. This is decreasing. However, we have the same case. We have the same case of decreasing without any limit. So we say this also diverges. Now, if you recall back to the example we solved in the previous video, we had 1 minus 1 divided by n plus 1 at the end. Now, if you consider the sum to infinity of this expression, we'll be working with the second part of 1 divided by n plus 1, as this contains n in it. Now, if you increase from n is equal to 1, you have 1 by 2 at n is equal to 1, you have 1 by 3, then 1 by 4. So as the value of n increases, the fraction, the total value, decreases. Now, if you plot a graph and sketch a curve using these values, you have a curve like this, where as the n value increases, the total sum, the fraction 1 divided by n plus 1 decreases to 0. It decreases to 0 and does not decrease below that. So we can say that as n approaches infinity, 1 divided by n plus 1 approaches 0. It decreases till the limit of 0. So we say this expression converges. Now let's look at a different sequence which also decreases. 4, 2, 0, minus 2, minus 4. This one is decreasing with a rate of minus 2 in each term. So this does also decrease, but this one decreases without a limit. It will keep on decreasing till negative infinity. So this sequence diverges. Now, how do you know which one converges and which one diverges? How to check for convergence? So there is a very easy way for that. Let's check out an example. 5x cubed plus 4x squared plus 1 divided by 2x squared plus 5x plus 3. Now we divide the whole thing by x squared. Why do we divide by x squared? Because x squared is the largest power of x in the denominator. So we divide the whole thing by x squared. And what we have remaining is 5x plus 4 plus 1 by x squared. The whole thing divided by 2 plus 5x, 5 by x, plus 3 by x squared. So when x approaches infinity, what happens is when you consider the fractions, the 1 by x squared, the 5 by x, the 3 by x squared, these fractions approach 0. The 1 by x squared approach 0, the other two also approach 0. So in the next line, these three fractions vanish when x is approaching infinity. So in the next line, you write 5x plus 4 divided by 2. As x is approaching infinity, you replace x with infinity, and you see that the numerator is equal to infinity at x is equal to infinity. So we do have the fraction approaching to infinity as x is approaching to infinity. So you can say that this fraction diverges. Now let's look at a second example. 3x squared plus 5x plus 4 divided by 7x cubed plus 9. So what is different in this example? The highest power of x cubed, lies in the denominator. In the first example, we had 5x cubed. The x cubed was in the numerator. So in this different example, let's look at what happens when x approaches infinity. So as per the last one, we divide the whole thing by x cubed, and then we try to find out what happens. So as x approaches infinity, all the fractions approach 0. All the fractions vanish, and we have remaining 0 divided by 7. So 0 divided by 7 is obviously equal to 0. Now 0 is a constant value. So 0 is a limit. As x approaches infinity, the total fraction approaches 0. So this fraction converges. Now we'll take a look at the third example. In this third example, the highest power of x, x squared, belongs both in the numerator and in the denominator. So if we divide the whole thing by x squared and then remove the fractions approaching to 0, you have 3 by 7, which is not 0, but 3 by 7 is a constant value. It is a limit. So this fraction does not converge to 0. Instead, it converges to a different value, 3 by 7. So this fraction also converges. Now that we know how convergence works, we can solve an example question. So looking at the example question, they provide us with an expression ln of 1 plus x to the power n plus 1 divided by 1 plus x to the power n. They ask us to find the sum with the limits of 1 and capital N of this expression. Write the sum in terms of n and x. So we can write ln of the expression ln of 1 plus x to the power n plus 1 divided by 1 plus x to the power n as ln of 1 plus x to the power n plus 1 minus ln of 1 plus x to the power n. This next line comes with the use of a logarithmic formula, which you learned in your grade 10 or grade 11 syllabus. So we now write the terms by applying n is equal to 1. N is equal to 1 means ln of 1 plus x squared minus ln of 1 plus x. Then we apply n is equal to 2. Ln of 1 plus x cubed minus ln of 1 plus x squared, and we keep on increasing the value of n until n is equal to capital N. Now notice how the first term, ln of 1 plus x squared, cancels out with the minus ln of 1 plus x squared. So every term cancel out with each other. What we have remaining is minus ln of 1 plus x and plus ln of 1 plus x to the power n plus 1. So we write those in the next line and then simplify that into ln of 1 plus x to the power n plus 1 divided by 1 plus x. So this is the simplified form of the summation. Now, they ask us to find the sum to infinity of this expression. Given three scenarios. The first scenario being x is equal to 1. So first we'll take a look at x is equal to 1. Going back to the original expression, you have 1 plus x to the power n plus 1 divided by 1 plus x. If x is equal to 1, you have 1 to the power capital N plus 1. Now 1 to the power anything is equal to 1. So if you replace x with 1, you have ln of 1 plus 1 divided by 1 plus 1, which is equal to ln of 1, which is 0. So this one, when putting in x equal to 1, the summation of the series converges to 0. Now let's consider the second scenario of x is greater than 1. X being greater than 1 means x squared is greater than x, and x cubed is greater than x squared, x to the power 4 is greater than x cubed. So as you increase the value of n in the power of x, the total thing increases to infinity, approaches infinity. So if you put this in the original expression, you see that the numerator approaches infinity, so the total thing approaches infinity. This series, when putting in x is greater than 1, diverges, and the sum to infinity is infinity. Now we'll look at the third scenario of x greater than minus 1 or less than 1. So if this happens, x to the power infinity approaches 0. How does that work? Now let's use two examples of x is equal to 1 by 2. For x is equal to 1 by 2, x squared is equal to 1 by 4. its cube is equal to 1 by 8, and as you increase the power of x, the total thing approaches 0. Now let's consider the negative value. If x is equal to minus 1 by 2, x being equal to minus 1 by 2 means x squared is equal to 1 by 4, its cube is equal to minus 1 by 8. Even though the sign changes, this also approaches 0. So putting in this in the expression, you have ln of 1 plus 0 divided by 1 plus x. So that means ln of 1 divided by 1 plus x, which you can write as ln of 1 minus ln of 1 plus x. So simplifying that, you have ln 1 is equal to 0 and you have minus ln of 1 plus x. This is the limit. This is the limit of when x is greater than minus 1 and less than 1. So this series converges to this limit. Depending on the value of x, the limit also changes. So that concludes our video. That concludes our video on this chapter of series. Thank you very much for watching till the end. We'll continue uploading on more topics, so be sure to tune in the future. Hope you had a good time. Goodbye everyone, and have a great day.